What really is important when you start coding in Go is to make sure that you don't just master all the different technical things, but you also make sure that it's basically like a toolkit. So my talk, elegant and flexible marshalling using type definitions. The whole mindset behind really is to build in a more scalable and maintainable way. As James was saying in the talk, you end up with big code base, a lot of code. Golang is amazing, it's verbose, and it's important to make sure that you have the right organization, the right structure, and everything works well together. So yes, as I was introduced, I'm co-founder and engineer at Custodian alongside Jeremy Hindle and Charles Clegg. What we are doing is basically a go-to management platform for core owners. So our stack is React and TypeScript on the front end, Golang on the back end with dgraph, a new amazing graph database, which I would encourage you to learn more about after this talk as well. And yes, special thanks to Jeremy Hindle, my mentor as well. So now let's go. So on the agenda, because the mindset really is to build in a scalable and maintainable way, I wanted to first go through quickly, domain-driven design, which is our philosophy, how we are building. It's really important because once you've really grasped your hand around how am I going to build, how am I going to define my entities, how am I going to have internal types, and how are they all going to be interconnected. Like this is the really hard part in terms of maintenance. What is difficult usually is not even just to start coding, it's once your application grows and you need to add more features and the user and business needs change, you need to make sure that you have a very strong structure and you understand exactly what's going on there. So, after that, I will go through, entities, domains, subdomains, services, repository, kind of all the little building blocks that we have in our code base and how everything is structured together. Then finally, I'm going to go through, marshalling and elegant custom marshalling, which is, an example of what I will say before, which is, how to actually practically, apply this mindset. How can you marshal and how can you convert types between your internal types in your REST package, for example, to your services in a way that is really elegant and well done. And then you can extend this thinking to not just marshalling, but other parts of your code. So our high level approach is, as I said, DDD, domain-driven design, which really is a way to look at things from top to down. So Eric Evans, which is the person who basically invented DDD and theorized it, he said, when we are developing a software, our focus should not be primarily on technology, it should be primarily on business or whatever we are trying to assist with the software, the domain. So what the domain really is the business logic. So what, especially as a startup, what we're thinking is, okay, how do we do our code? The way that we really thought of it is hand to hand with product, hand to hand with what do we need to do now? What is the business priority? And so for a very concrete example, our domain is garage management, not cars. You would think, it would be cars because we basically are a management platform for car owners, and therefore it would make a lot of sense that, we start with cars and then do all the different bits. But actually, like even just the language is important. It's garage management, which means that within it, you can have all the different sets of tools really nicely, one under the other, nicely organized. So you can have subdomains under the garage management, which is, for example, communication. How do you communicate with your users? You'd have by email, via text. You may have some different rules. If this happened, then email is better. This is better for text. You can have all of your business logic within it. Authentication, fast storage, verification, etc. Rather than just, for example, like cars, users. Which at the very end becomes, like, in my opinion, very difficult to detangle when you look at, how we're going to do this next. So it's basically a huge different kind of building blocks or code structure. You have, a number of high-level concepts that can be used in conjunction with one another and modify domain models. So, for example, you have the entity, which is where you would define all the different schema of things. For example, you have the user entity, the core entity, etc. The kind of core domain type, which is going to be used in services and which is going to be the core domain, which is going to be translated back and forth between the other packages. You then have, for example, the repository, which is where you define the collection of methods that the infrastructure implements. And this is where you'd have your database. For example, we use dgraph. All our dgraph methods are inside that. It has its own internal types, which converse back and forth from the services to the different entities type, for example, cars or users again. And then the service and operation or form of business logic around the entities used from, for example, the REST resource, and usually then it would be delegating to the repository methods back to the REST resource. It's basically the crossroad point. And this is usually in the service where you would have your business logic. So for example, this is where you would make sure that the person who is requesting to see the cars is meant to. This is where you would do, checks on verification, like is this safe to show that to this person or not? So you'd have all your business logic inside of that. So, when you're a software engineer, usually you only think about this kind of stuff, like the tactical design tools. What really is important when you start coding in Go is to make sure that you don't just, master all the different technical things, but you also make sure that it's basically like a toolkit, and you really are organizing them in order to solve a specific business problem or a specific business goal. So you'd have this, as a service, as a subdomain within the domain, to garage management, and then you'd have, again, like file storage or communication users, and that's really how you organize your code. So as an example of a high level code structure, we would have in our code base, like entities, which have all the core domain types, for example, address.go, user, task, cars, you name it. And then you'd have, the domain with subdomains. For example, domain in our case, as I said, would be garage management, which have all those different subdomains, which contains the service, where you have your business logic, where it gets called from the REST package, and then it understands what to do with this request. It's like, okay, well, who should see this? Is this something that makes sense? Which kind of function would it make sense for me to call from the database to get something super specific from them? And then you have the REST package, which has its own internal types, which is something we'll go through, and obviously the resource, the handler, middlewares, etc. Then you have the repository, which is where, as I said, you have dgraph, but let's say you were using more than one database or other external things, you'd have them there as well. For example, within dgraph, you'd have internal types, and then obviously, all the different functions, methods that you have there. So why DDD? Well, at the company level, I think it's great. We are a startup, so we don't have so much of that problem yet because we're quite small, but we still really love to have product and development, the software engineers as close as possible to the user experience, to what, our users want, to what our users need, to what we might build in the future. We want, our software engineers to be very, 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 very conscious of why they are doing something, whether it really helps advance the business. Usually there is a lack of trust sometimes from business, lack of knowledge of how the system works. And I've certainly seen, different reunions sometimes in other companies where there was a sort of fight between, people representing the clients on the sales side and engineers, where it's like, no, it's going to take, that long and that's it. Or then there's a lack of communication. Not because anyone is ill-intentioned, but because usually there's a wall of misunderstanding between the two and communication. And with DDD, it forces the software engineers to understand what's going on with the business. And, it makes sure that everyone is on the same page and that they're working really together during the whole development process. And on the dev team level, it's amazing as well. It's really easy to communicate. When I look at the code base and Jeremy, co-founder, is working on a new subdomain, for me, it's really easy to understand what's going on. I look, at the entities and understand that, hey, I did this and this and that. And then, it's so much easy for me compared to, for example, JavaScripts, to look at, when I hover on the type and it highlights and I understand what's going on and I see that how it communicates with the rest of the code. It just is very clean. And also, it improves flexibility because there's so much around, types and internal types and everything needs to be encapsulated and independent from each other, but they still have only one thing which will hold them all together, which is, for example, the core domain type, the entity. Well, thanks to that, it basically really does improve flexibility. We can be working on things which are completely different and then make our changes independently of each other over time. So it's a nice, very new way to look at it from like a components perspective. So you have the entire system as a whole, but you kind of break it down to pieces. You do have some things to consider before, diving in DDD and seeing whether that's something that you'd like to consider for your own project or for your companies. Is one, it does require robust domain expertise. You need to make sure that the people working on a specific domain are fully briefed, know fully what's going on. And it may be difficult for them when they are deep experts to kind of switch between the different domains, because it's like a whole different world of its own. And then it may be ill-suited for highly technical projects. The reason why is because, well, DDD really did make sense for Custodian because we are very complex. We have very complex business models. We don't even have one business model. We have different business models. We have, like what can be done is insurance, logistics, on calls, like all the different tools that you have, MOT reminders. It's very volatile. You have many, many different things which have nothing to do with each other but the car, and a lot of random connections, and everything is very nuanced. And so, for us, DDD really does make sense. However, if you have a very monolithic business model and it's not very multidimensional, and however you are, providing one technical solution to something super, super complicated, then, I don't think this is going to be the right fit. So do take that into account. If you want to read more about this, I would recommend the book of Eric Evans, who basically invented domain-driven design, or at least put words into it, tackling complexity in the heart of software. So that was my short intro on DDD. I think it's important because, especially in my experience with Golang, when I started doing my own projects to learn it at first, when I changed my mind on, the kind of features that I wanted to have on the app, or what the user should be able to do or not be able to do, I ended up having to rewrite a lot of the code, and it ended up being super messy and verbose, not in a nice way, in a way where it was just too much, and it was difficult to find my way. It was less flexible than on JavaScript, right, where you can just do whatever you want. You shouldn't be doing that. That's why we were using TypeScript. But DDD really does forces you to kind of, from the very start, put all the structure there, and that's something that's incredibly underrated. If you don't think, for example, that it's important to spend a lot of time on that. Maintenance takes way more resources and companies and time than creating something from scratch. So when you start, it's where really you want to make sure that you're doing the right thing before you start coding, before you start typing anything on your keyboard. So let's just have a look at this one last time, because then when I'm going to go through internal types, entities, and conversions, you kind of know where is the things that I'm going to talk about. So it's not here. I'm going to talk about the internal types within the REST package, right, for marshalling, which is going to be made from the entities. So there and there. So first, let's go through entities and internal types. What's the difference? Should they differ? And we do quite a lot of conversions. There will be 3 different types that we are using in total for doing just one transaction. So you may be there like, why are so much conversions needed? So let's go through this. Entities. The entity of, let's say, X is your core type for X, designed from a business standpoint. So for example, I give a to-do example here. If you're someone who is a tech blogger and you have a bunch of tutorials that needs to be updated because the programming language just released an update and this is obsolete, well, then you have to, here tutorials, just to explain these examples, you would have the IDs of the tutorial, which is an array of IDs of tutorial, which you can assign to do. So that's why this is there, just in case of confusion. So usually your entity would, of a specific type, would a specific thing would always, we always contain all the different possibilities. We always contain all the different properties, right? This is not where you're like, oh, I only want users to be able to see this or this or that. This is where you're like, okay, this is what everything on the whole platform we can store inside of a type. This is the entity, and this is all what it does and all what it contains. And other types can be made from it or to it. And this is where, when you do other types from it or to it, you can limit what you want on it. This is where you can do some checks like this. So for example, I will have better code showing, no worries, but just to give you a first idea, the payload types, for example, are the types which are internal to the REST package, or types which are made from the entity type which we have just seen. So for example, let's say that I'm on the to-do app and I receive, create to-do requests is a type of to-do. And what I'm going to receive, let's say, is just a JSON string, which is going to say UID of task or to-do and body of to-do, right? And this is an update. So you'd have, okay, update to-do request is of type to-do. So all of your different possibilities of payloads on your REST will have their own specific types, which are made from the same type of to-do. And it is very important for multiple reasons, which we'll go through. So one reason is, of course, to restrict what could be sent back or coming in. Other big reasons are, separation of concerns. For testing, it makes life way easier to just have, everything is separate. And so you'll see how elegant this can be, because for translating this back to the entities that to-do type for the services is going to be very easy. You just cast it. So yeah, just nicely presented so you have a better idea how it feels. You have all your different payloads with their own, like, the same type. Let's go through this function, and hopefully you'll understand it after my explanation of unmarshalling. So let's go first through marshalling. So marshalling, what it means is both unmarshal and marshal, for those who know. It's basically how you can translate in Golang between JSON payload and a type, or between a type or a struct into JSON. Okay, and that's being done thanks to the package encoding/JSON, which is also very important. Whatever I'm going to show you won't work if you don't, import this package, which is, with Golang. So it's nothing too weird or that is strange to us. Like it's something which is very universal in normal. So I encourage you to be looking in this package and reading documentation on it. It can do really pretty powerful things. So here, for example, we are marshalling. So what we are doing is, okay, well, we have a type of person, and we want to send it to the front end, and therefore we want to translate that into JSON. So what you do is you do JSON.marshal, like the person. And yeah, you can do that thanks to this package, and reverse for unmarshalling, where you have JSON and then you're using unmarshalling to basically, translate strings into bytes. Oh, good. So now let's go back to our custom marshal function. So I think I put it there. Yeah, exactly. This is the way that I'm going to go through this function. Is I'm going to show you all how it looks in general, and then we're going to break it down and see what's going on. So you have, let's say that you have someone who is trying to update a to-do. Okay, and they're like, okay, well, new title is this, and they give you the UID of the to-do. What you have is, on update to-do request type, right, which is basically a to-do entity type, which is made from the to-do entity type, you have a method which is unmarshal JSON, right, which takes basically this type, okay, and will unmarshal it to JSON. So what's going on there is you have an internal type here, which basically can receive, can be populated later with anything that you deem should be possible on this function. So let's say I only want people to be able to update the title, the body, due status, and complete status. If someone is trying to update, created date, let's say, or, created by, they wouldn't be able to update it. It would just ignore it. So in this internal type, basically, you are basically, in a way, filtering, making sure that the information that you receive is, is correct, before passing it down to the type that is going to be unmarshaled for the JSON payload. So what you get here is you have the update to do request, which is your type. You're going to populate it, okay, with what has been here unmarshaled from this type here. So let's say here you have, for example, the title of your request is going to be the title of what has been unmarshaled here, because you passed the data, right, which you have shaped in this type, this internal type. Do you see the UTRQ? Okay, this is the internal type. And then it unmarshals the data that you give, right, inside, and it morphs it in that internal type. And then what you do is you basically populate this type with what you've just done. So for example, let's say the user has sent the new title, you send the new title in your data, basically, which is unmarshaled, morphs it into this. The title of this is here, and you set the title of your update to the request to be that, exactly just that. If it's not given, it will ignore it. That's fine. So now what? Let's see where and how this runs. So now we're going to go to the REST package where we have the resources for the to-dos. So again, I'm going to break it down. First, I would like you to kind of have a look at this code, see whether it makes sense, and we're going to try to understand each bit of it. So this is what I have in my REST package. I have an update to do. What I'm doing is, okay, I'm going to get the user ID, the to-do ID. In our case, we get it from the context. And what we do is we create, a type, which is of update to-do request, as we've seen in the payload types, right? Which is made from the to-do entity, which contains everything that the to-do entity contains, absolutely everything. So even if this update to-do request contains created by, and it doesn't exist in the function that we've seen, it will still be valid. It still exists. It's exactly like the to-do type, just different, but the same. And what we do is we're using, there are basically 10 different ways of doing that. We are using as well Gochi. We are using, the JSON decoder, again, from the package that I mentioned earlier, the JSON package, which is really important. You must import it, or else you can't do this kind of stuff. And when it decodes it, right, and morphs it into this type here, what this does is that it satisfies the marshal and unmarshalling JSON interface. As in, because on this type here, we have this method, update to the request, which is an unmarshal JSON method, because it satisfies the interface, right? It does it. So if you don't know what's going on, basically it does it as if it was magical and automatically. But what it does is that it checks, and if it has seen that on this type that you gave, there is a function here, a marshal JSON, right? And you will use that custom one, rather than the one that we've seen above, where you do it directly on it. Just in the marshal, here it will be custom, because you've put it in on this interface there, which you're using here. Okay, so this will run the function that we've just seen before, and it will populate the data from the JSON that you've received into this internal type, which is then put as the content of this type. And now the really cool thing is that what you do is just, you just can, in one line, translate it back into the entities.todo, which is then ready to be just directly used and delegated to the update to do from the service. So for example, let's say that we had the domain, to do management and then to do. Then it would have a different bunch of functions which can receive, to do entities back and forth. And then when it receives the update to do with a to do, which is the core entity type, it basically decides then, okay, well, we're going to send that to the database on the repository. So this is where you do it. So you can see that how it populated the entity to do without any other function needed, just does it like that. Why? Because update to do request has been made from it. So it is quite powerful. Now, I don't know if I have time. I think I have some time to go through the last bit. The last bit is basically how you can do the same, but on the marshalling side. So this was basically unmarshalling, right? Marshalling is when you have the type and you're like, okay, I'd like to translate that into JSON for my payload. So custom marshal function is basically, the same mindset, simply reversed. Is you create your custom marshal function, which is, again, satisfy the marshalling and marshalling JSON interface. So will be done here automatically, not automatically, but as if it was done automatically for you. And same for that, I'm using, you can see, to-do response, okay, which is another type made by, as now you must guess, the to-do entity. So let's see, I have some time, I think, to go through this. So let's see how, for example, you would create your own custom marshal JSON function on the to-do response type. So you have your type here, to-do response, entities that to-do important. And then on this, you have your own custom marshal JSON function. So what you do is same thing. You have your internal definition, right? Structure, which basically here it obviously it returns more than when, for example, we wanted to have an update for requesting a request for updating the to-do. For example, there was no created at, because when you go back to the front end, you want to return all of the objects of the task. So that's why you can basically choose here, depending on your business needs, what you want to return. So in here, we want to return everything. So you define your structure. And then what you do is, again, you basically populate with the structure that you made, right? Something that is you basically populate the task response type, which is, again, of entities.todo, which you're going to form into JSON at the end, JSON.marshal. And it will go back to the front end. So this is what you do. TR, do you see TR? TR is basically that task response internal type. And you basically populate this up until JSON.marshal. And this will return the JSON that you'll send back to the front end. So that's how it goes. So do you see the difference between the custom marshal function and the custom unmarshal function? It's the same, it's slightly different, but it is the same concept of having your internal struct, converting the two. Here returns nil, which is normal. The other, you need to return a payload to the front end, so it does return the JSON. And yeah, and they are both, all the internal types are custom to the needs of the REST package. It still morphs it back to the very normal, like, core type of, to-do entity, which can be then used, back and forth from the service, which contains, the next, main business logic, and calls the database and back. So, you can do the same kind of conversion, conversion tips from the side of the database, where you'd have your own internal types and other types of conversion, but the mindset is the same. You make sure that you have a separation of concerns, that the types that you have really are fitted to the needs and to the business needs, both business needs, but also the needs of the internal package. And then you communicate in between them with a full object, which may or may not take some properties, which is basically like a kind of transaction between them all. So yeah, thanks for listening. Let me know if you have any questions on this. Even, outside of the talk, you can message me and I can try to answer your questions if you have any.